So just another day reviewing for next Tuesday's check-in. We got equations and inequalities, linear or nonlinear. I'm just identifying the functions or graphs. Linear functions, that's finding slope, finding y-intercept, or finding like an entire function from a graph. The scenario graphs and angles. Every one of these could be on the inactive. All right, so we got to be able to do them with and without a calculator. So if I got that equation there, what do I need to do first? Distribute. Whenever we have parentheses on an equation, that's our first step. We're going to distribute. So when we distribute, the number in front gets distributed to each part on the inside. So 2 times x is 2x. 2 times minus 9 makes minus 18. We got a plus 4 equals 21 minus 3x. So after I distribute, what's the next step? We got to combine like terms. The things that are alike on the same side of the equal sign. So that, in this case, I got a minus 18, I got a plus 4. I don't include the 21 with that, with the constants, because it's on the opposite side. Okay? Everybody clear on what I'm saying there? So we're just combining the minus 18 and the plus 4. Since the signs are different, when the signs are different, what we do? Subtract, and we use the sign of the bigger number. So that 2x stays as is. 18 minus 14, or minus 4 is 14. And the 18 was the minus, so we got minus 14. Then other side, there wasn't anything to combine, so it stays the same. All right, once we get there, now what? Yeah, the variables, we got to get them on the same side, all right? Not everything is going to have combining like terms. Not everything is going to have distributing. And you might even see a couple that don't have variables on both sides. For the most part, 8th grade math, though, definitely we're starting with this step, at least, okay? So I've got 2x and a minus 3x. Which one should I move? Move the 3x, okay? The reason you want to move that is it's going to be giving you a positive coefficient. You want to move the lower number, and if one of them's positive and one of them's negative, move the negative, okay? So since we have the minus 3x, I'm going to add 3x. It cancels it out there, so we do the same thing on the other side. 2x plus 3x is 5x. We got minus 14 equals 21 now. All right, now what? We do the opposite with our addition or subtraction. So we got plus 14 to each side, cancels there. I got 5x equals 35 then. And the last step, we're dividing here. We do the opposite to that multiplication, so 35 divided by 5 gives me 7. All right, everybody follow? If you got an equation, those are the steps we do. We distribute if we can, if there's parentheses. If there's like terms on the same side of the equal sign, then we combine those. Then we move the variables so they're on the same side. Then we do the opposite with our addition or subtraction. Then we do opposite with multiplication and division. You know, we got those steps up on our poster over there too. All right, so then that's equations. We got to identify linear or nonlinear. So this one here is just asking which one is nonlinear. Who thinks they can tell me which one is the nonlinear? Hunter? Nope. All right, so let's look at each of these. A, what looks weird about A? Or different maybe? Anything? We got that like kind of x over 4 looks a little bit different. Y'all, basically all that would be is if I had 1/4 times x, when you multiply with a fraction, you put it like over 1, and that's all they did, okay? So that's okay, because we could have a slope of 1/4, right? So that would be okay. B, anything look weird on that one? Not really. That's y equals mx plus b. It's just kind of got the order changed, right? Weird about C. Yeah, we got like all sorts of different stuff that looks a little bit weird, right? We got that fraction there, and while that by itself isn't weird, when you put it together, it makes it look a little different, right? But if we look, A right there, right, had the x on top with a 4 on the bottom. Going down here, that's not really any different, okay? It's just got a little like +3 to it. It still basically works out to the same thing, and having that extra 2x, that's just like a combining like terms problem, right? So that can still be okay. What about the last one? Thing on D. It's on the bottom, and that's the part that's not allowed, okay? So nonlinear functions have exponents on variables, have variables, especially x, as a denominator, or you'll see things like square roots. Those kind of count as exponents, okay? Any questions on that? X on top of a fraction, that's fine. X on the bottom, that's when it gets to be nonlinear. All right? If you had Desmos, you can always put each one of those in, but this stuff's usually on the inactive. All right, we need to find the slope. Find slope. Change in y over change in x. The biggest mistake I was seeing yesterday was people mixing up x and y. What are my y values? 3 and 6. It's the second one each time. So we're going from 3 to 6. What are my x values then? 2 and 8. They're the first ones. So from 3 to 6 is how many? 3. We're going up, so that's positive. 2 to 8 is how many? 6. Again, going up, so it's positive. This is another thing we sometimes make mistakes on. What's 3 over 6? A half. Yeah, a lot of y'all keep wanting to put 2, okay? When the top number's smaller, it's going to be a fraction, right? 3 goes into both of those, so if we divide it by 3, it simplifies to 1/2. Everybody good with that? Slope definitely can be fractions, can it? We saw those a lot with our graphs especially. All right, so angles more often will be on the calculator active, okay? So if you want me to bet on it, I would bet that the angles usually will be on the active. Does that mean they have to be? No, especially not for the check-in, okay? So the first thing we got to decide, if we got like a transversal like this, are those angles different or the same? They're the same, all right? You know, we have that one, and then the corresponding ones down here all match up. The ones I didn't put dots on, those all match with each other. There's only, if I got 2 parallel lines and 1 transversal, there's only 2 different types of angles or 2 measurements. So if they're the same, how do we solve it? Put them equal to each other. You know, if they're the same, they're equal to each other. So I got 8x minus 10 equals 6x plus 30. It doesn't matter which one's on which side of the equal sign. No. I put the one with the bigger coefficient on the left just because it's And that makes it a little easier sometimes for some of y'all to see. All right, so do we have anything to distribute? No. There's no parentheses. Do we have any like terms? No, they're on opposite sides. I got a variable and a constant on each side. I can't combine variables with constants, and I can't combine things on opposite sides. So I got to move my variables then, right? Which one should I move, 8 or 6? 6. 6 is smaller, so I subtract 6x. Cancels on the right side. That gives me 2x minus 10 equals 30. Now what? Add 10. Yeah, we got to get rid of the addition or subtraction. So I got subtraction here. I get rid of it by adding 10 to each side. Cancels. So I got 2x equals 40. Now what? Divide. What's 40 divided by 2? 20. So we got x equals 20. Now, sometimes they ask for the measure of an angle, right? We didn't do any of these yesterday, but if they ask for the measure of the angle, that means you take whatever you get for x and you got to plug it in to the angle it's asking for. Okay, so we would do 8 times 20, that's 160, minus 10, 150. Everybody good with that? We'll do maybe a couple more like that on Monday. One other thing that's a little bit different. I've seen some problems that look like this occasionally. We got to figure out what value of n would make the equation have no solution. For an equation to have no solution, we need it to have the same coefficient on each side, but different constants. Okay, so the number in front of the x is going to have to be the same. All right, so the n's on the right side. Everybody see that, right? So if we look at the x's on the left side, we're going to have to make them match. So if I distribute there, how many x does that make? 8x. And then we got that, right? 8x plus 4x is 12x. On the other side then, if I distribute there, I'd have n times 3x, right? Everybody okay with that? When you distribute, you multiply, right? It's just got kind of extra variable to it. But I need 12x. So what's n have to be? 4. Not a horrible problem, right? We kind of follow how that works. Ask it for infinite solution or no solution. That's what you're looking for. You need to make the coefficients match. That's usually going to be the easiest way. So let's have y'all try the one. Y'all try this one. Same idea. We got to find the value of n that's going to make that have no solution. What? All right, so what did I say we were worried about? Our x's, right? So do the constants really matter? All right, so if we pretend the constants don't matter, let's just get rid of them for right now, okay? So if I multiply here, I got 15x. 5 times 3x. Everybody okay with that? On the other side, I have n times 2x plus 3x. All right? So I got rid of the constants, right? All right, so now I'm going to do one more thing. Does x matter? Not really. The number in front of the x's is what matters, right? We need to make those matching. So if I get rid of the constants, now I'm going to get rid of the x's. So let's rewrite this. I got 15 equals 2 times n, so that's 2n, plus 3. Everybody kind of follow how I got that equation? I got rid of the constants first, did the multiplication I needed to with the distributing, and then I make an equation here. So who can tell me what the answer would be there? 6. We need these two sides to be equal. We could go ahead and solve that like an equation. So then I'd have 12 equals 2n. I divide, so that means my n has to equal 6. Because what we're looking for is just making the coefficients match. So the constants don't matter at all, and the x's really don't matter at all. The x's are only used to identify which ones are the coefficients, really. Okay? So if you pretend they're not even there, we get a nice little 7th grade math equation, right? Any questions on that? Those are a little bit trickier way of doing a question like that, but